Okay, so we've talked about graphing lines, we've done systems of equations, and we solved them by graphing. Now that leads us to linear inequalities. Remember what an inequality is. It's basically the same thing as an equation, except instead of an equal sign, we have an inequality symbol. So, what is a linear inequality? It's similar to a linear equation, except it has an inequality symbol. So, just like when we solve equations and solve inequalities, linear inequalities have that same rule, except this time we have a y and an x. So when we graph their solutions, okay, it's going to look different. So what is the solution? It's all ordered pairs, x, y, that make the inequality true. So remember when we graphed just a regular inequality, x is less than 4. We had to shade the side of a number line. Well, let's think now. We have y is less than or equal to x plus 5, for example. So there are a lot of ordered pairs. So we're still going to shade, but it's going to look a little different. Also remember, it's an ordered pair that makes the statement true. So let's look here. You have 2x minus 3y is less than 15. That's in standard form. But all I'm doing here is I'm determining if 2, 5, the ordered pair 2, 5, is a solution. So I take my inequality, I replace x with 2 and y with 5. I do my math, so 2 times 2 is 4, 3 times 5 is 15, 4 minus 15 is negative 11. Is negative 11 less than 15? It is, so that means 2, 5 is a solution. That statement is true. Let's go to the next one. I'm still taking the same inequality. I'm replacing x with negative 1 and y with negative 7. 2 times negative 1 is negative 2, and negative 3 times negative 7 is a positive 21. When I do negative 2 plus 21, I get 19. Is 19 less than 15? No. So that is not a solution. It is false. So let's try the same thing. I take my inequality. I replace x with 3 and y with negative 4. 2 times 3 is 6. Negative 3 times negative 4 is 12. 6 plus 12 is 18. Is 18 less than 15? No, so it is not a possible solution. Then let's go look at my next one. I write my inequality. I replace my x and y. I multiply. Is 0 less than 15? Yes, so it is in fact a solution. Why is it important to know how to do this? Well, when we graph linear inequalities, it's how we can show all the ordered pairs. Remember, there's going to be a large amount of ordered pairs that are possible solutions. So you're not going to be able to find that just by solving. So in order to do this, we'd write it in slope-intercept form. Okay, and then we graph just the way we graph a line. However, we use a dashed line for less than or greater than symbols, and a solid line for less than or equal to or greater than or equal to. Okay. We use a test point. So we pick a point. Now I need you to write this down. You pick a test point that is not on the line. Usually I pick 0, 0 or 1, 2. As long as the point is not touching the line, you can pick it. Okay? Now, what do I do with that? Okay, so let's look at this. My inequality is already in slope-intercept form. So I would just identify my slope, which is 1/3, and my y-intercept, -5. So I begin at -5. I'm going to go up 1 and right 3, and up 1 and right 3. Now, look at my symbol. It's greater than. So that means I'm going to have a dashed line because none of the points on the line are included in my solution set. Once I've done this, I need to pick a point. This is what I mean. You have to clearly pick a point that's on one side or the other of my line. 0, 0 is a good point to pick. Here's why. I'm going to replace it in my equation, or inequality, I'm sorry. So I'd have 0 is greater than 1/3 times 0 minus 5, which becomes 0 is greater than 0 minus 5. 0 is greater than -5. Is that true? Yes, meaning that point is a solution as well as any other point on that side. So if your test point gives you a yes, if your test point gives you a true statement, okay, you shade where the point is. So please add that to your notes. If true, shade where the point is. If false, shade on the opposite side. And we're going to go look at some of that. So if you need to pause now to write that down, as well as all the work. Okay, let's try this one now. Again, it's in slope-intercept form. So my slope is -2/1, and my y-intercept is -1. So I start at -1. I'm going to go down 2 and write 1. But I can also go up 2. But if I go up, I have to go left. When you look at your inequality symbol, there was the or equal to, meaning your line is solid, meaning points on that line are possible solutions. So I'm going to take my initial inequality and pick a test point. I'm going to pick 1, 1 this time. I can do that. If I plug in 1 to x and y, and I do my math, is 1 less than or equal to -3? No, that statement is false. It's a no, meaning I don't want to shade that point. I want to shade on the other side. Because what you're shading, I said it in a couple slides prior, what you're shading are all the possible solutions. So everything here shaded in that light blue is a solution to that inequality. Okay, so let's take a look at how we would graph a linear inequality when it's not in slope-intercept form. First, we'd copy our problem, and we'd isolate y by subtracting 5x from both sides. That leaves me with -2y is greater than -5x plus 12. I'm dividing absolutely everything here by a -2. So what happens when it's a -2 is I have to switch my inequality symbol because I divided by a negative. Okay, so this is now the inequality I'm going to graph. I have a slope of 5/2, and I have a y-intercept of -6, because 12 divided by -2 is -6. I place my point at -6. I'm going to go up 5 and right 2. I'm going to do another one, up 5 and right 2 from that second point. Now, when I draw my line, it needs to be dashed because it was just a less than symbol. Okay? So I need to pick a point. I'd pick 0, 0 because it's clearly on one side. And I'm going to plug it into the solved equation. You can plug it back into the original if you'd like. Either way, you're still going to work this through, and you're going to end up with 0 less than -6, which is false. 0 is greater than -6, so it is a no. So I'm going to shade where the point is not. So everything you see here shaded in blue is a solution. So if I had to pick a point that was a solution, I'd pick a point that is in the shaded area. So I would write that down if I were you. Okay, So Mrs. Nell and I are noticing some students struggling on how to graph horizontal and vertical lines. So take a look here. I only see one variable. So really my slope is 0. So remember what a line that has a 0 slope looks like. It's horizontal. My y-intercept is -4. So I can go plot a point at -4. What this inequality means is all my y values are going to be -4. So it's going to be a solid line because it says less than or equal to. I'm going to pick a point, but what I'm going to do is I'm going to pick a point on the y, right on y. Why did I pick y? Well, take a look at your inequality. Your inequality says y is less than or equal to -4. So if I plug in that y value, is -7 less than or equal to -4? Yes, it is. So I'm going to shade all those points below. If you also go back and read the problem, it says y is less than or equal to -4, meaning you're going to shade anywhere that y is smaller than -4. Okay? So this is something to write in. Whenever there is just a y, meaning there is no x variable, it will always be a horizontal line at the number that's there. So there's only a y here. So there's a horizontal left to right line at -4 on the y. Okay? So let's go look at this one. Now I have no y value. Okay, so there isn't a y value in my inequality. This one actually has no slope. And there is no y-intercept. There is no y. Okay, so what this means is I'm going to go where x is 7. Okay, and anywhere on my line, my x value is going to be 7. I'm going to draw a dashed line because it's a greater than symbol. I'm going to pick a point on my x. And this one I'm going to pick 1 to keep my work easy. When I plug 1 in, is 1 greater than 7? No, it's not. So I shade on the opposite side of the line. Okay? So it's important to commit to memory. If x is by itself, meaning there is no y variable shown in your inequality or equation, it will always be a vertical line at that number. So this said x at 7. So you go to where x is 7 and draw a vertical line. So this is something you have to commit to memory, okay? Don't panic. You might want to go back, rewatch this video. Anywhere that is shaded, any point in there is a solution, and that's what you need to get from today.